AI projects by design can have a lot of uncertainty, which makes it really challenging to determine whether a certain idea is worth pursuing or not. However, there is a way to de-risk AI ideas before making significant investments, doing a proof of concept, or a POC for short. Welcome to the 5th episode of the AI for Business course, your ultimate non-technical intro to the world of AI and how to apply it in the real world. In previous episodes, we explored the fundamentals of AI, looked at over 80 different machine learning use cases across various domains, and learned how to select our first AI projects. Today, we'll kickstart the initial phase of bringing these ideas to life through proof of concept experiments. We'll be exploring many aspects, including why POCs are especially critical for AI projects, how to plan and execute them and set the right success criteria. We'll explore different POC plans for real-life use cases, and most importantly, how to use the outcome to plan for production. So with that said, let's dive right in. So why do we need POCs? 3 main reasons: testing, feedback, and production planning. The first reason, testing. They allow you to answer essential questions quickly, such as whether AI is the right approach to solving the problem, if you have the required data and skills, whether the outcome is serving the business, and how much it will cost for a production system. Feedback. Getting early feedback from stakeholders who will be using the AI solution is essential. This ensures that the solution is addressing their needs and requirements, increasing their buy-in and adoption of the solution. The third reason is production planning. POCs help with production planning by giving a sense of the complexity, time, effort, and cost involved in building a full-fledged production system. This is crucial information for any business looking to implement AI as a real production capability, not just as a lab experiment. There are 10 elements to take into consideration when planning an AI proof of concept. Those are the problem, hypothesis, scope, success criteria, data, modeling and tools, infrastructure, deliverables, team, and finally, time. Let's explore each element by using an example use case, automating industrial visual inspection. In this use case, we'll be using deep learning to automate the detection of defects in products or parts instead of heavily relying on manual inspection by subject matter experts. Let's start with the problem, which should be a pain to solve or a value to bring. In this example, the problem is the manual inspection of industrial products, which is time-consuming, resource-intensive, and leads to increased costs and reduced efficiency. The hypothesis is how you think the POC will contribute to the solution. In this case, AI can help automate the inspection process by detecting defects in industrial products, leading to faster inspections and reduced inspection costs. The hypothesis is that AI will enable the team to conduct more inspections faster and free up the time of workers, ultimately reducing the number of inspectors needed. Scope defines the nature of work to be done. It should be limited as much as possible and really focused on building the model, not a full production system. Examples of limited scope include focusing on a certain subset of products instead of every product that you have, making the POC scope on a certain geography or a subset of problems instead of the big problem you're trying to solve, and so on. By narrowing down the scope of a POC, you can really limit the amount of variables and complexity of the overall project, which would make it easier to manage and test. In this example, the POC will focus on developing a computer vision deep learning model to detect 4 types of defects in images of industrial products. The model will be trained on a dataset of 5,000 annotated images, and the evaluation will be done on a test dataset and new images. If you'd like to know more about training or labeled datasets for AI models, I recommend you watch the first episode of this course. Setting clear success criteria is essential for a successful POC. The experiment needs to show a significant improvement over the current state of things, whether this is going to be measured in terms of quality, speed, cost, or something else. Success criteria could be based on specific business metrics, such as, for example, higher click-through rate for a use case like personalized recommendations, as well as the model's accuracy, which could be expressed in different metrics, such as precision, recall, intersection over union, mean average precision, RMSE, or something else, depending on the model type and the specific problem you're trying to solve. It's important to set realistic target model accuracy for the proof of concept stage. While high accuracy is generally desirable for a production system, that's not really the focus of this stage. Let's say for your real production system, you would love to have like 90-95% model accuracy. For a proof of concept, you can target something like 75% accuracy because it's understood that by time, with more data and better modeling, you're going to reach that 95%, right? But for the sake of the experiment that you'd like to run real quick to assess the feasibility, you might want to set lower accuracy objective. In our visual inspection example, the success criteria include an accuracy of 70% precision and 80% recall, and the model's ability to inspect 100 images in under 1 minute. The fifth element is data. This is basically the datasets required to do the POC. In this example, the datasets include 5,000 images of industrial products with annotations indicating the presence or absence of defects. Modeling and tools define the modeling technique and any tools, services, or libraries expected to be used. In this example, the POC will use Amazon Lookout for Vision as the primary cloud AI service, optimized especially for defect detection. However, if the accuracy is not satisfactory, the POC may also explore using Amazon Recognition or even custom model training using a deep learning framework like PyTorch. The infrastructure element defines the hardware, storage, and compute required for the POC. In this example, when using AWS Lookout for Vision, no dedicated infrastructure is needed. Users can leverage the service directly. Everything from training to inference is managed within the service itself. However, if we're going to train a custom model using a deep learning framework, for example, like PyTorch, a powerful on-premise or a cloud virtual machine will be required. This machine should have enough processing power, memory, and storage to handle the size and complexity of the dataset and the training process of the model. For example, if you're training a deep learning model, you're going to need the machine with a powerful GPU. The infrastructure will also need to provide a way to deploy the model in case a prototype application will need to interface with it. One example of a virtual machine from Amazon is the Amazon EC2 P3 2x large instance, which is optimized for high-performance computing workloads such as machine learning. This instance type includes a single NVIDIA V100 GPU, which provides significant acceleration for compute-intensive training tasks. In addition, it features 8 vCPUs, 61 GB of memory, and 1.5 TB of NVMe SSD storage. We can consider this or a similar on-premise machine if we're going to adopt a custom model development methodology versus a cloud-hosted AI service like Amazon Recognition or Lookout for Vision. The deliverables section highlights the specific outputs that you're going to get from the POC beyond the model itself. So it's understood that you're going to get a trained model, ideally with a good accuracy. Perfect. But what exactly do you need beyond that so that you can continue to build on top of that POC and build a production system, ideally? Here are some things that are typically received after the POC is done. 1, code. You need the code files for all the stages of the POC, whether it's sourcing the data, cleaning it, processing it, any feature engineering work that was done in case you're using classical machine learning algorithms, and so forth. So you need those source code files so that your team or other consultants can eventually build on top of that work. 2, documentation. You need documentation for all the pieces in the proof of concept, how they talk to each other, and stuff like that. And you need a summary of the outcome and how that outcome was achieved. Number 3, you probably need some sort of knowledge transfer. In many cases, you have some consultant or an AI company helping you do a prototype or a proof of concept, and then you have your own data science team, right? If you would like your team to carry on the work, you need some sort of knowledge transfer from that consultant or external company to your team. In case you don't have a team, that's not probably going to be required if the same company is going to still build a production system. You might also need a prototype application that interfaces with the model. So here's the thing. Once you are done with the POC, you would like to test that, maybe with new data, see how it works. There are different ways that you can test that pilot, right? Whether you have a data science team or someone who understands Python so you can just run scripts in a notebook, for example, or in a Python environment, right? Or if you're not able to do that, or you need an easier way to interface and test the model, you're probably going to need some sort of a web interface or a mobile application or a desktop application, some sort of a graphical user interface that can integrate to the model, and you can use it as a way to test it and provide it with some data and get some output, for example. So a prototype application might be required. And then finally, and the most important thing here, some sort of recommendations on what to do to scale that pilot or experiment to our production system. This is one of the most important things of our proof of concept, that you learn a lot in that experiment. And the kind of recommendations on what to do next are really critical to be provided. So to summarize, you need code resources, documentation of the system, and a summary of the results, some sort of knowledge transfer if it's required, a prototype application if you require some sort of a dedicated app to interface with the model and test it, and finally, some recommendations on what to do next and things to consider if you would like to scale that to a production system. In our example for the industrial visual inspection use case, the primary deliverable is a computer vision model, a convolutional neural network in that case, that can accurately detect defects in industrial products. Deliverables will also include the following: a data pipeline that can efficiently pre-process and transform raw images into a format suitable for training the model. The data pipeline can also be used to update the model with new data in the future. A code repository that contains the source code for the data pipeline, model training and evaluation scripts, and any other tools developed during the POC. A report detailing the development and evaluation of the model, including a description of the dataset used for training, the model architecture and hyperparameters, and the evaluation metrics. The report should also include a discussion of any challenges or limitations encountered during the POC and recommendations for further improvements. The POC will also result in a prototype application, in our case, a web-based interface for uploading images and receiving defect detection results, or an integration with an existing inspection system. The team should ideally include resources covering the AI and data engineering piece, the domain knowledge piece, and the project management aspect. In our example use case, the team actually consists of a data scientist, an inspection engineer, and a project manager. Finally, the POC should ideally take somewhere between 3 to 8 weeks, more or less. Again, the objective is to test the idea quickly with minimal investment instead of spending a lot of time on it. In our case, for the visual inspection use case, we're going to take about 1.5 months for the proof of concept. I highly recommend you include these 10 elements when planning for your proof of concept experiments, whether you're doing it in-house or outsourcing to a contractor. These 10 elements will help you structure the planning of your proof of concept. For better familiarity with this tool, I have included 4 different examples for POC plans, one of which is a generative AI use case, in the video description. So check those out. You're going to find the detailed proof of concept plans for these different use cases and use these as examples to understand the methodology better and apply it in your future experiments. Throughout my work with more than 100 customers that I have helped a lot of them pursue successful POCs, I found that there are some critical questions to address after the POC stage. I'm going to go through these questions one question at a time right now and provide some reflections on how you should think about it. The first question is AI the right solution to solve that problem or not? AI is amazing. It is so powerful. It can solve so many problems. But guess what? Sometimes it's just not the right solution. Sometimes more traditional techniques could be more efficient in solving that problem versus AI. After trying machine learning techniques in the proof of concept, you need to really assess the ROI. Is it significant? Are we talking 2x, 3x, 10x, something like that? Again, speed, quality, time, customer experience on any of these metrics, or the return isn't really that significant. Again, sometimes more traditional techniques could be more efficient, and if that's the case, don't get too fixated on AI and try to brainstorm and think about other use cases where AI could really bring significant return on investment. The second question is, what is the expected level of accuracy boost we can get for the model for a real production system versus the proof of concept? Proof of concept act as good reality checks for what we can potentially achieve if we invest more for a production system. Let's say you're getting 70% accuracy for your model. Maybe with more data and better modeling techniques and more iterations, we can achieve, like 85% or maybe 90% accuracy. The question is, would that be enough for your use case or not? Sometimes that's enough, sometimes it's not, depending on the use case. For self-driving cars, for example, you can't really go with that. You have to hit like 99.999% or something for your perception systems because it's really vital for those cars to see what's on the road, right? While for other use cases, let's say automating visual quality inspection for industrial use cases, maybe for your use case, you can just go with 80% accuracy, right? It can save you a lot of time. So depending on the levels of accuracies you're getting for your model for the POC, you can start estimating what level of boost you can get for a production system and have the decision whether this is going to be enough or not, and decide to invest more in that experiment or not based on that. The third question is, if you aren't getting good results from your POC, what are the reasons for that? And is it worth doing a second round of a POC or moving to a production system? Is it worth allocating that investment or not? And what kind of changes we need to do to ensure better outcomes? If you're not getting good results, there are usually three main reasons: insufficient data, insufficient skills, or working on the wrong problem. Let's take this one by one and have a closer look at it. Insufficient data. Sometimes you either need different data sets or more from the data that you have already. Sometimes the data that you have that you're working with simply does not have enough predictive power for you to use and find relationships and stuff like that and make predictions. Let's say, for example, you're trying to forecast retail store demand or retail demand in general, and you're using only historical sales data for that. If you're not getting good accuracy, probably you need to add more data sets, like, for example, weather and promotions and historical marketing campaigns and maybe economic indicators and stuff like that. Now you start adding these data sets, you might get better accuracy. Sometimes you're only working with 1 or 2 years of data. Maybe you need 5 or 6 years of data historically to solve that problem. The question is, in either case, is it feasible to get these data sets, whether it's more from the data that you have or different data sets? If the answer is yes, that's usually a good sign. Then maybe it's worth having another round of the POC, getting more data, and seeing if you can get more results. The second reason could be insufficient skills. Let's say you're trying to solve a computer vision problem, the very example we have at hand, automating visual quality inspection, and you're not getting good results. Maybe it's not about the data. Maybe it's about the team skills. Maybe you have a team in-house who have great experience in predictive analytics, dealing with tabular data to make predictions about demand or predictive analytics for other use cases, but they haven't worked on deep learning computer vision problems before, and they're still learning, and they might not be familiar with the latest architectures, the latest tips and tricks to optimize the hyperparameters, the latest tips and tricks to achieve better accuracies and stuff like that. So maybe that's the reason. In that case, it's not a showstopper. There are other routes that you can proceed with. You can hire a consultant who have been working on these problems before. You can consider partnering with a technology company who have been solving these problems before, right? And see. But if you don't have access to these, and at the same time you don't have a meaningful way to upgrade the skills of your team, you need to make a decision here, because it's not expected that you're going to get amazing results if you're not able to improve either of those. The third possible reason for not getting great results is, as we mentioned in the previous points, maybe you're just working on the wrong problem. Maybe you're trying to solve a problem that could be really solved with traditional non-AI techniques, and you're trying to force AI to solve it, right? And I find this happening a lot of times, by the way. Some customers that I've been working with, they are really excited about AI. They have some mandate to use it to solve problems, so they rush into using it to solve specific problems that honestly, other tools could solve it more efficiently. So if that's the case, then again, you need to consider those other tools and move on to other use cases. The fourth question is a really important one. Are you going to be using off-the-shelf models or services or tools to build the production system after the POC, or you're going to need to build it from scratch? That's a very important question. The POC will give you a very good chance to explore the different tools and services in the market, the different cloud AI services, the pre-trained models, the open source tools and stuff like that, and see if you can leverage any of these when building your real production system. If you have tried a lot of these tools and you see that it's not providing, decent results, maybe you need to consider building a system from scratch. That has its own advantages, right? You have a lot of control into crafting exactly the workflows that you want. You can control so many different things, but at the same time, it comes with a cost. It requires probably high technical skills, and it will probably take longer time, right? On the other side, leveraging off-the-shelf tools, solutions, and cloud AI services can save you a lot of time. We can proceed with using it while having less AI experience in-house, but it might not give you the flexibility of building things from scratch. There is no right or wrong here. You have to weigh the pros and cons of each, but you need to understand, based on the effort that you have put in the proof of concept, what are the available solutions out there that you can leverage, and if they are enough or not. Answering this question will help you identify the complexity of a production system and the expected time and budget for it, which are very important to assess before committing a specific budget or an investment or team effort to solve that problem. Question number 5. What is the total expected cost for a production system in the light of what we've seen in the proof of concept experiment? Here's the thing. For the proof of concept, usually we just focus on the science aspect of the problem. We focus on building a good model with good accuracy to test the hypothesis of our problem, right? For a production system, you're going to need to scale this across the enterprise. And for that to happen, you're going to need to move from the limited scope of the POC to a fully fledged scope. You're going to need, for example, to take care of different items. Each comes with its own cost. For example, the ETL or data pipelines. How are you going to get input data from different systems, integrate it, process it, clean it, and pass it to the model? And then, how are you going to get data or predictions out of the model and feed it to different information products? In order to do that, you're going to need software engineering to integrate the model with different systems in your company. You're going to need this flow to happen in an automated fashion, right? In a POC, usually you run the model in a Jupyter notebook, for example, or run a Python script. In a real production system, that's not going to work. You're going to need this flow to be automated, right? So there is a software engineering cost, infrastructure cost, ETL cost. There is ongoing maintenance and support. Sometimes the model results change by time, like they degrade, for example, and different types of drifts could happen. So there is going to be a need to potentially continuously retrain the model, redeploy it to production, stuff like that. So you're just going to need to take care of these different items, assess the cost associated with each, and build a business case. For the kind of return that you're expecting from a production system, with more data and more iterations, and the kind of cost you're looking at for this production system, how is the ROI looking like? Is it justifiable? And if yes, then definitely proceed. If not, then maybe you reconsider cutting some parts of that production system, pushing some parts to a later stage, and focusing on the core aspects instead. At the end of the day, the proof of concept should give you a good idea of how much cost potentially a production system would look like, and that will help you in taking the decision and building the business case to justify these investments. These were just some examples for how the POC can help you ask the right questions, get the needed answers to plan for the next stage, building a production system. I hope that today's episode was useful for you. I hope that you have learned how to take your idea to action and start planning for that experiment and what are the main elements to take into consideration when doing these experiments. And for the next episode, we're going to be looking into a very interesting subject, building AI capacity. We're going to talk about different things. We're going to talk about building AI teams, what kind of skills and resources and talent you need to have based on your stage, based on what you're trying to do. There is no, black and white here. There is no one right answer. There are different flavors of this based on what you're trying to do. And we're also going to be looking at the option of outsourcing and compare these two different options together. Building AI teams versus outsourcing. Each one has its own pros and cons. We're going to be exploring that. And we're going to be looking at so many different scenarios for what kind of AI team you might need to have in-house, and some tips and tricks on how to hire the best AI talent and retain them. If you liked today's episode, I really appreciate if you share it with others who might benefit from it. And, like the video on social media and on YouTube. And with that said, see you next episode. And thank you for your time today.